Hi, welcome to Teardown Tuesday. Why am I sitting on a big orange sheet with a photocopier? Well, this is the puppy we're going to tear down today. All 80 kilos or 180 pounds of it. Why? Because we can. And if you've been following my tweets, you'll know that I found this thing in the garbage room. It was dumped in one of the bins, one of the big bins there, but got it out and I don't think it's working. I don't care. I scored another one actually from the same garbage room that does actually work. But they tossed this thing out. It's a Panasonic DP2310 and it should be fun. There should be lots of interesting stuff in here. So you know what we say here on the EEVblog, don't turn it on, take it apart. And as I said, it's a Panasonic DP2310 and I powered it up here and it does actually work. It's got one of these touchscreen displays, but unfortunately, you know, it's no good. It's missing all of the side panels and the trays and the whole lot. They were just missing and all sorts of stuff. So it's really no good to keep, but we're going to tear the sucker down. And apparently this was like a really top of the range mono, it's not a color, mono photocopier, networked photocopier, you know, probably 10 years ago or so. Collating things on the side or whatever you call it. And I just checked the user manual. It does seem to be about a 2003 vintage, so it's bordering on, you know, 9 or 10 years old or thereabouts, and you know, all sorts of things are missing, the side stuff and the paper collator on here, although the paper can actually come out from here, but all the cover plates and the trays, it's all gone. So it should be an interesting teardown, because these photocopiers are great. If you can get your hands on one, it should have lots of cool motors and sensors and all sorts of other gear that you can reuse for hacking projects. And this could get a little bit messy, hence the orange cover sheet here, so I don't get all the black toner on the carpet, because you know, it's already all over the damn thing, and you know, I think it's going to be really messy when we start tearing this sucker down. But well, let's go. Could take a few hours, so I expect this to be pretty complex. If we have a look at the counter there, it's only a 6-digit one, but it shows 136,740 copies. I don't know if it's rolled over, but if that's the case, that's actually not many, and that's not much for a huge copier like this one. And as you can see, there's the trays, where the trays go down in there. It's actually higher than this. It's got extra trays which go on the bottom, but they were missing from the whole thing. And there's the toner. And I will try my best to sort of document the teardown of this thing, but there's bound to be so many things involved in this. It would need hours and hours of video to cover them all. There's part of the exposed drum down in there. There's lots of black toner all over the place, but this is what she looks like. There's a metal box on the back, which presumably contains power supply electronics, cable going up to the top head there, and that's the model number of the like the sheet feeder head scanner head on the top. And there's the USB and 100 base T Ethernet interface. It's also got a flash memory card interface. And if you believe the rumors, these photocopiers are supposed to have hard drives in them that store every document ever scanned. So it'd be interesting to see if we find a hard drive in the sucker. One interesting thing I found is this. If you're wondering what it is, there's a matching one over here, which might explain it. Here we go. Can we get that? Yeah, there we go. It locks in place like that. What are they? They're carry handles. It's got one on the other side as well, because this thing's so darn heavy, you need these to pick the thing up. Alright, that was pretty easy. We took the top scanner part off and we've got to look at our first board here. These two plungers here presumably go down to a micro switch which detect when the cover is actually closed. Why it needs two like that, my first guess would be so that when you have you know, some sort of book in there, you scan in a book, it's got two different levels of you know, in 2 different levels of detection. So the first one would detect, okay, you've got that down there. The next one detects flatter ones. I don't know. That would be my guess. We've got a rather interesting single inline device, power device here. Probably some sort of, I don't know, driving some sort of motor or something like that, with a whole bunch of, look at that. That's a massive bundle of cable coming out of there. That's just absolutely enormous. And, well, yeah, I guess we can get that board out. There we go. It's an SLA 7042. I don't know. I haven't got time to check. Now, this little gear here is interesting. If I turn it, you can see the scanner plate move across like that. There you go. So that's, I don't know whether or not that could be controlled by the board here, because there's a couple of cables coming over here. There's another cable going off over here to some sensor over here, which I think detects when, there's this sensor here, probably detects when this is all the way back in line with there. So that'd be my guess. So this board probably is sort of like a motor controller or something like that for the scanner head. And here's what we're interested. This cover plate just folds down like that, and ta-da! Oh, look inside of it. There's 2 huge boards there with a massive BGA device there, another huge BGA device up here. Lots of stuff happening in there. We'll take a good look at those boards later, but that's very, very exciting. I like it. And it's obviously designed for access, because they've got this nice little retainer here. I like it. And clearly this top board is like a PC, some sort of Intel PC architecture. We've got a PCI slot here, we've got a DIMM memory module up here, we've got the Ethernet and USB and compact flash, we've got more memory, we've got some custom sockets around here which look a bit unusual, but it's, you know, it's a custom design board, but it's clearly some sort of PC architecture. And if we take a look at the bottom board down here, it is clearly one of the main controller, if not the main controller for the motors and the sensors. Hasn't got direct motor drive on it. You can tell by the lack of power stuff. There's a couple of power resistors down here, but nothing much doing on there. But look at all the cable harnesses everywhere, going off, snaking their way through these to probably a ton of, probably a dozen separate boards, as we've already seen on the top there. Probably individual motor, driver and sensor boards, all coming back to this main controller here. Now, taking this plate off is rather interesting. Look at this. It's like a big, some sort of big flywheel or something like that. That's obviously the paper. I think that's the paper mechanism. So that's like, I don't know the mechanics of it all, but I can feel that that is sort of linked through to the paper handling stuff on here, and the drum and stuff like that. This is clearly the motor, which is actually a PCB mounted motor. If we take a closer look at that one, there it is. It's actually, looks like a PC mounted motor, and you can see the traces in there. We'll take a better look at that later, but that's rather interesting. And then we have some fans up here, just a couple of fans in there. They're filthy dirty with, look at that. That's why I've got the drop sheet here, and the toner, it's just filled with toner. One angled fan out there, up there, like that's probably taking the heat out of the, it looks like the top scanning plate or something like that. And this one, I don't know, maybe the fuser or something like that gets hot. So, yeah, it's a mess though. And here's this PCB mounted motor I was telling you about. There's another controller in that SIL package, the SLA6024, and hey, made in China from Japanese and foreign components. And look at that, there we go. Look at that excellent worm drive on the back there. It's brilliant, and that goes through there and dries those cogs in there, which presumably, like as I said, part of the paper handling mechanism or something like that. We've got a controller on the back here. Beautiful. I like it. And here's our IEC mains input filter. As you can see, big choke, big common mode choke there. Couple of filter caps, couple of MOVs, and that's about it. Fuse, which might be a little high rupture capacity one or something like that, but yeah, not much doing there. And down under here we have some little teeny tiny motors. Check out the wires going to them, extremely thin. Therefore, the paper drive mechanism for the tray, clearly, because they go into little cogs in there on the one of the paper drive, one of the paper cassette things, sorry, so they're what drags the paper out of the tray up into the main mechanism on the back here, past the drum there, and and then through the copier, through the fuser and all that sort of stuff to give you your final print. There's some nice little motors there. And this board's rather interesting. It's kind of like the controller for the motors we just saw. They go into there, but it's very old school. Single-sided, through-hole parts, jumper links, the whole show. Now the thing that's starting to impress me already, and should be impressing you, is just the sheer amount of systems engineering that's gone into producing one of these things. And we've barely even tore this thing down at all. Just all the metal brackets and the parts and all, imagine the design team having to put together all this stuff. It's just, absolutely incredible, let alone all the paper handling mechanisms we haven't even got into yet, all the drives and everything. It must be a massive design effort to produce one of these photocopiers. I haven't got a clue how big the team would be, but it would be massive. I mean, just designing this neat mechanism for the pull-out handle here that locks into place. They've got all the springs and the moving parts and the brackets and the... unbelievable. And this board here is clearly a high voltage board. 2 dead giveaways, all of the transformers on there, and the warning symbols, high voltage warning symbols. So that's used to generate the high voltage that's required to actually pick up the toner, because that's how I believe these things work. They generate a really high electrostatic voltage, and then the toner clings to the drum as it passes over. So clearly that is some sort of board which generates, I'm not sure what order of voltages. If anyone knows, let me know. And once again, they've done that cheap as chips, single-sided. They'd all be custom transformers, of course, all through-hole parts with the links, and very, Spartan sort of layout, but it does make it cheap, makes it very repairable, and I guess you're not really constrained for room inside these photocopiers. They're really big devices, but, all these things have to mount on custom brackets. It's just crazy. And we have 3 more motors in there driving the paper handling over the drum and over the back here, because normally this would have a back panel on it, and of course you saw the motors down there before which pick up the paper from the paper cassette, and then it feeds it up through here, and these 3 motors in there handle all that aspect. And then you've got the big drive in there, if you can see that. There's some monster gears and drive mechanisms inside there. That'd be to turn the drum, and the rest of the mechanism which feeds the paper through the copier. But geez, these things are complex, let me tell you. There's just the sheer amount of engineering in these is phenomenal. Now, one of the things I find really fascinating is the cable harness in here. I've got these two fans here, and these are connected through to this harness, which goes down through here, but it also goes up to something else up on the top board up here as well that we looked at right at the start. But it comes down through here, which comes into this connector, which went into which went into our main controller board down the bottom. But then that also branches off. It's not even separate. It branches off to something else way down in the bottom down there. Maybe there's more fans down in, inside there, and this is like the fan harness or, something like that. But it's just incredible the amount of effort which has gone into just doing these cable harnesses, getting them all correct, and there's obviously some procedure to assemble this whole damn thing, because it's not obvious when you take it apart without like a step-by-step disassembly guide. Now this is interesting. We can see from the drum there, all these sprogs and mechanisms in here. This has got some sort of sensor cable coming out of it. Clearly that's not a motor. And these ones down here we looked at before, we can actually get the label on that now, and that's from the something or other clutch company. So I don't know, are these some sort of clutch mechanism? I'm not quite sure if they're motors or they're some sort of clutch thing with a sensor, because the wires are very, very puny coming out of them. So it looks, yeah, they're very, very loose. So I'm thinking it's some sort of, I don't actually think it's a motor. Probably just some sort of clutch. And here we go, these little clutch mechanisms just pull off the shafts here when you take the retaining clip off the back. So let's take a look at one of these things. There it is, Ogura Clutch Co. Made in China. But there you go, DC 24 volts, and that spins very freely. So it'll be interesting to check out what these things actually do. Well, check this out. This is one complex drive mechanism. This is for probably the majority of, good majority of the paper handling, certainly the paper pickup and passing over the drum and stuff like that. Just the engineering that goes into, systems engineering goes into getting all this right. All the cogs down in there, it's crazy. You can see them all. They're all staggered. They're not just, they're the angled cogs, and it's just imagine designing that mechanism on its own. Even this cute little mechanism here, which is covered in toner, it's got for 6 cogs in there. Yeah, it obviously connects various things together. Yeah, somebody probably spent a month getting that right. Okay, what we have down in this bottom paper handling, or paper feed mechanism, I guess you could call it, where the paper first comes up from the tray, it looks like it's got a sensor here, and that's like probably a paper jam or a paper position sensor. There looks like 2 there going off to these cable harnesses, and that's, where you often have to unjam your paper. They can get caught and jammed up and gunged up in here, and not fun at all. Anyway, if you're not aware of the basic mechanism of a photocopier, I'll just run through it, as a rough guide. It basically, motors extract a piece of paper from the tray down the bottom here. It comes through the feeder mechanism, and it passes by the drum here, and the drum contains a coating of toner on it, put there by what's called the corona wire, and that's a high voltage wire which electrostatically coats the drum with the toner material, and the paper passes by that, and it's exposed via the light in the mirror. You see that big light come on when you open the photocopier, and if we move the wheel, here it is. There's the tube. Okay, there's the light tube in there, and it's got mirrors, which actually, you'll notice that the mirrors are, these triangle mechanisms in here are actually mirrors, and they direct the light down onto the toner, onto the drum, which the paper is passing over, and that will, and then that will coat the paper with the toner material where it's exposed, and then it goes up into the fuser up here, and I'm not sure if you might be able to see the fuser rollers in there. They're basically high temperature rollers that fuse, hence the name fuser, that fuse the toner onto the paper. That's why your paper comes out hot, and that's why they've got caution, high temperature on here, because you don't want to go touching the fuser in there, and then the mechanism pushes the paper out and shoots it directly out. And that's pretty much all there is to the operation of a photocopier. So in concept, they're not that hard, but the mechanics and the engineering of actually getting them right, you know, to a high degree of precision, a high degree of reliability, is incredibly complex from a systems engineering point of view, as we're seeing here. Now, you're probably wondering about the drum itself and why it's green, why it looks, you know, it's coated. They always have a very similar look. It's actually coated with a semiconductor material, just like they make silicon chips out of, but it's probably a selenium instead of a silicon or a germanium, but basically you can use any one of the different types of semiconductor materials to coat the drum with. And there's our big beefy cables and connectors going into our fuser there, because these things take a lot of energy to heat these suckers up. Now, it's interesting to note, up in this section here, they've actually got connectors going through this wall here, so that it looks like we can just pull out this entire mechanism here, and so it all assembles, whereas most other cables don't bother having like a penetrator connector going through like that. But they have done it here because they deem that's all part of the assembly or disassembly process. And here's the main paper handling mechanism, which contains some feed drives and things like that coming from the motors and the mechanisms we saw earlier, and it contains the fuser as well that heats it all up. So, and this is where the paper eventually comes through, and there's a couple of once again, I think there's a couple of sensors down here, paper stuck sensors. Now let's see if we can explain the travel path. The paper comes in through here, this past the drum, of course, it's already gone past the drum, and it comes into here, which then goes down, which then goes through the fuser rollers down in there, which will fuse the image onto the paper. Then there's these rollers and mechanisms in there. There's some sort of paper guide mechanism, and that's why they put this on here, because this is where paper jams, of course. They've got the big paper jam point, and this is where you want to kick the photocopier and just beat the living crap out of it, like in The Office, the movie. If you haven't watched it, fantastic. And then, yeah, it shoots out of there and comes through, comes through here, and eventually, or it goes up through there and comes out these rollers here, and that's where it shoots out into, there it is, there's the exit path there, which then it shoots directly out of there, and that's where you see the paper come out. Magic. And this is nice, look at this, we have an old-fashioned electromagnetic solenoid. Look at that. Bam, turn on the current and boom, it latches that in. That's probably some, I don't know, some sort of maybe paper direction mechanism, or, and yes, I think that solenoid was basically a paper direction guide switch. So this is how it does double-sided copying. This is the exit path here, as we saw, but of course there's another path up the top here which can feed the paper into there and then bring it back down, so that you can, it hides it up in there, can flip it and then bring it back down, and you can print the other side. And if you thought the big clunking power switch on the side of the unit is actually a real clunking power switch, nah, it's one of these stupid soft switches. Little wimpy piece of garbage that is. And there's another little sensor board here. I'm not actually sure what this one does. It seems to... Hey, look at that. That's a little board there. It's got what, a BA10324 on it. And that looks like maybe a little speaker or something like that. Not entirely sure what that little board is doing. And down here we obviously have some sort of critical set mechanism, because they're done in here with Loctite, and this has like a little, a position display which rotate, you can move that arm up and down and presumably set something. I don't know what, some sort of angle of some... And if we take that paper exit tray cover off, you can see various cable harnesses running inside. We've got some sort of black box. Maybe that's the power controller for the toner, for the fuser, sorry, something like that. Yeah, not entirely sure, but not much else doing. There's probably some extra electronics under here, so, geez, I don't know. This has taken a long time, but we're going to have to finish it off. Like, it's quite modular. There we go. We can actually lift off this entire section. It actually is built in sections, and as I said right at the start, it's actually bigger than this. You can add on more paper cassette stuff down the bottom. So get this off here. Oh, look at that. Brilliant. Ta-da. And well, this is certainly a teardown, folks, let me tell you. There we go. Ah, look at that. And here's one of the complete paper magazine add-ons, like, the paper drawer slides in there like that. And here's the rollers on top, which actually take the paper up and then feed it up through here, and then, boom, up through the side of the photocopier all the way up, and past the drum and past the fuser, and then out. So that's it. So these are all quite modular. Once again, you can get access to paper jams and fixing paper jams and things like that down here. And that would have, there's a sensor for the door closed on it. So, when the photocopier pops up and says door open, door number 8 is open. Well, there it is. And check out all of the cogs and everything that drive all of this. It's really quite complicated when you get down to it. It's a lot of engineering which just goes into making the paper cassette mechanism. Crazy. Let's have a look what this thing is. I've undone that. There's a couple of wires going into that. I'm not sure what... There's a springy thing there. I have no real idea what that actually is. Open it up. Hey, there's a motor. Hey, look at that. Here we go. There's a motor in here and a whole bunch of cogs which drive something or other. There you go. Man, this thing has more cogs than you can poke a stick at. It's incredible. And check this out. We have another flip down mechanism, and that's definitely the driver board for our fuser. You can tell by the color-coded wires and the huge, big, beefy power stuff on there. And nothing terribly surprising on here, just a gigantic SCR there on a medium-sized heatsink, another device in there. Once again, single-sided. There's a few unpopulated things, maybe for the upmarket model, photocopier or something, but yeah, single-sided, bare bones, few caps, few optocouplers there by the looks of it, SCR, and that just drives power to the fuser. And we've got a huge switch mode board here, and you can see the split, primary, secondary. We've got the optocouplers there, the isolation transformer, and we've got a couple of caps in there for noise, switching noise suppression, and a big 270 microfarad 400 volt cap, couple of common mode chokes here, and so I don't exactly know what that's powering, but it's they've put a lot of effort into that, and it's from Nichicon in Japan. Go figure. Curiously, we've got a some sort of choke down here, which looks like a, you know, it's in like a transformer type configuration, but it's not a transformer. It's only a, you know, it's only a dual wire coming out of it. So obviously some form of choke. And here's the top user control panel. Nothing surprising here at all. We've got the main control board. It's got a big quad flat pack there, some memory, another quad flat pack, some miscellaneous circuitry. There's a backlight driver there, of course, for the LCD. There'd also be an LCD driver on there, presumably another board for some switches on the front, and switches again, and there's a little pop-out thing here for the memory backup battery, if I can get the damn thing. Too hard, but it does slide out. Now this is all rather interesting. This is a very complex sort of arrangement here. This plastic mechanism where there's all the buttons falling out there, but this is a, you know, just that panel alone, really quite a bit of complex engineering has gone into, and molding has gone into doing that thing just alone. I mean, just the three-dimensional envelope of designing that front user panel is quite a lot of work. And somebody's gone to the effort to design a PCB that clips in there just for the LEDs, which, you know, light up that doohickey on the front, which, you know, it gives you an indication of what mode the photocopy is in or something like that, but, you know, it's a bit of a wank factor. It's gone to all that effort. Unbelievable. And somebody's had to go into the trouble of designing and getting these molded, all the buttons. So you've got to do that in 3D, or the button inserts there. And here's the LCD module and the touch panel as well, which goes onto that. It's just a 4-wire interface. So that's the touch panel overlay, and that's a big graphic. I'm not a graphic display. I'm not sure what the resolution of that module is, but you know, you can reuse that. There's a backlight. Neat. You can get good stuff out of photocopiers. Now I'm very curious to find out what this is, because they've gone to a lot of effort to put it on its own bracket like this. It looks like, almost looks like there's some sort of motor in there, something like that. I don't know, but it's weird. They've gone to all the effort to, hang on, I can see something through there. Anyway, there's a, it's onto the harness here. It's pretty messy, but anyway, let's try and check it out what it is. It's almost as if this thing's like a secret black box or something. It's obviously not the secret hard drive we're searching for. That doesn't make sense at all, but it's just really weird. Very strange thing. I can't get that black plastic off. Aha, it looks like it is the optical scanning device somehow. So it's motor driven, and it obviously scans. It's because here's the optical window here, and it was strategically placed in there, mounted, and that's what it was hooked on to those alignment screws which we saw in the copier before. You remember those all those screws which are all lined up? That was aligning this box, aligning this mechanism up like this, which is what allows it to scan. Check this out. They've gone to a lot of trouble to put these plates on here, and it's almost as if they're like dampening plates or weights or something like that. So long screws in there. They really don't want this. They really want this to be quite a precise mechanism, I think. So they've got all this rigidity or weight or something to hold it all in place. So I'd say it's very critical. Look, all these different plates they've got to do what? Right? They're obviously there to sort of give it some sort of rigidity around this mechanism here, which looks like it's got some sort of motor in there or something like that. So I can only presume that there's some laser mechanism in there which is pretty precise, and that damps out any vibration or something like that. That's probably what it's for, I would suspect. It's really difficult to pry. Oh, hey, there we go. Ta-da! Oh, look at that! Beautiful! Wow, this is really something. Look at this. It is a precision laser directional thing. Here's the laser diode over here. We've got our driver board down in there. That would be our laser driving board. We'll probably take a look at. Might have to do maybe a separate teardown and play around with this, perhaps. And they've got some sort of lens in there, which sort of, I don't know, focuses the beam or maybe spreads it or something like that. And then, yeah, this is a PCB motor, and looks like is that like a head in some sort of sensor in there? You can see it, but anyway, this obviously spins around and directs it out through this lens system here, and it can scan across the drum like that and create the image on the drum. Beautiful. So this is how, of course, it prints digitally, because when you print with a normal photocopier, sure, it uses the light and mirrors and it can scan the image directly onto the drum, but when you print from your network, obviously, you know, you don't have that original image, you only have it in digital form. So this is how they do it. They scan the laser across the drum like that, and it'd be very precise optics, because you're talking 600 dots per inch with great precision and stuff like that. So really, it's got to be quite precise. That's why they have those dampening plates on the bottom of this thing. So, oh wow, it's fantastic. I'm going to have to figure out how to maybe drive this thing, and I've taken the whole thing to bits now. It would have been quite nice to see it going when you hooked it up to the photocopier electronics. But anyway, that's the laser diode mechanism in there. Not sure what type of what wavelength it is or anything like that. So that's really, I think, one of the more interesting aspects of a photocopier, the laser scanning mechanism to display the image. Brilliant. Oh, you could really have some fun hacking this thing, let me tell you. And you can see the sponge down there and that little arm on it. That's all part of the vibration dampening mechanism, I suspect, because any vibration on this thing is really going to throw it out of whack. So you've got those big, heavy dampening plates they've put on there, plus a bit of sponge and some sort of little springy bar there, and that all together mounted on that specific arm they put in there. They would have done their vibration tests on that, you can bet your bottom dollar, and that would be quite a stable mechanism, but it's got to work over the entire copier. So it's got to, you know, the thing sits in here like this, and then it's got to shoot out there onto the drum, because this thing's mounted parallel with the drum. It's got to shoot out there, so the whole frame has to be rigid and all mounted and engineered properly and calibrated and tweaked, and that's what those the tweaks down the bottom we saw, that adjustment mechanism was for trimming this laser. And Once again, it's all brilliant systems engineering. Complex stuff in, you know, all this complex stuff is in this, something like you use every day, like a photocopier. And who knew? Okay, now let's take a look at what was inside this mysterious box that was inside the scanning platform. Hey, what do we got here? What do we got here? We've got another optical mechanism. Check out that lens. Beautiful. Absolutely beautiful. And this is clearly the optical scanning mechanism used here, because it looks like this photocopier, while on the surface it looks like it has all the optical mirrors and stuff like that in the scanning platform to go directly from that, and the light go directly to the drum. I think it might be entirely digital, in that it scans it all through here. Once again, this is a different angle. It can scan the line across as, you know, it can scan the entire line across as that mechanism moves across the paper like that, an entirely digital path. So it scans it using this mechanism, and then it puts it out through the laser to that optical laser mechanism we saw before to put it onto the drum, instead of doing just the direct light using mirrors, you know, the old-fashioned analog technique. For photocopiers, this is probably all digital, but that is very, very nice. So there's obviously some sort of CCD there. There's a dip sort of package there, so I'm not sure what's going on with that, but yeah, probably some sort of CCD, and I'm not sure how they actually scan it across ways like that, because there's no, you know, ability for this thing to move. It's just fixed inside the scanning platform, and you can see the precision alignment screws and the springs on there and the Loctite. They've calibrated this thing to be spot on. Somebody sat there with the right tongue angle and screwed it in place and made sure they got the alignment that they wanted for this optical lens mechanism, and then they Loctited it down. And what we've got here is a high voltage driver board which drives the lamp mechanism in here. And of course that lamp mechanism scans across the page like that, and you can see how they're, you know, this one travels further than this one down here, and there's a geared mechanism in the back there which handles that, and a CCD lens mechanism sits in here like this, under here, and somehow scans across that entire line coming reflected from the mirrors in there, because you can see we've got the mirrors along here and here, so it obviously directs it, some sort of advanced optical mechanism, directs it down into the CCD sensor down there. Brilliant. Great engineering. I love these things. And what we've got here is a micro switch mechanism which goes down to the fuser board, and it switches off the fuser when you disconnect. Well, when you open the back thing here, it disconnects. So we can just pull the drum mechanism out of here, and there's not much in it. There's a couple of little, there's a little wire harness going through there, probably a sensor or something like that. I'm not sure what's on the end. We've got some rollers and things like that, but apart from that, it's pretty much just the drum itself. Oh, there we go. Hey, look at that. This is messy business, let me tell you. Oh, this is horrid. Okay, and oh no, toner's all falling out. This is bad. All right. Anyway, there are rollers and things in there, a few cogs, and where that drum mechanism came out there, you can see a PCB going all the way along here, and as you can see, there's LEDs on there about an inch apart or thereabouts, and I believe what they do is they light up, obviously, but that's the drum cleaning mechanism, because you light it up and you can get all the toner, you can clear the toner off the drum before the next operation. Any excess toner that happens to be still left on there electrostatically clinging to the drum head. So they expose it with light, broad light all the way across the entire drum. They just flood it with light, spin the drum around, and that can clean it. And that's quite a useful little LED light strip in its own right. Well worth stripping out of it. Brilliant. And I think that's about all she wrote for the photocopier. Teardown, there's not much left. It's pretty much just a shell with a couple of wiring harnesses left and the odd sensor and cog and things like that. There's still the little electromagnetic counter down there, which I'll get out. And but apart from that, you know, there's a choke down there, but no, it's just a shell left. So I hope you enjoyed that. It's been fascinating. Look at the amount of screws that I took out of this thing, and I'm not even finished. There's got to be another 100 screws left in this thing. That's just ridiculous. And here is the mess. This is what it looks like after you've torn down a photocopier, and this is a real fair dinkum teardown. Look at all the PCBs we've got left over. We might have to look at those in more detail later, but there's a whole bunch of good, great stuff you saw during the video here. And then there's a complete scanning mechanism there. We've got those laser scanner stuff, and oh man, you could really use these things to hack a whole bunch of really interesting and useful stuff. But yeah, I think it's done. I don't see any value in stripping down the rest of the frame, really, because we've got all the good stuff out of it. Look at that pile. It's ridiculous. Woo! That took, I don't know, a good 3-4 hours, something like that. Quite a bit of effort, but there's lots of cool stuff in these photocopiers. So if you can pick one up, you can get them next to nothing on eBay. People are practically giving them away. Or I found 2 in my, garbage room down in my building down here. It's crazy. That's where I got this one from. And I'm a mess. These things they've got toner all the way through them. They're horrible, but you can get some great stuff out of these. The optical mechanisms, scanning mechanisms, the motors, the electronics, brilliant stuff. Power supply stuff, high voltage generators, fantastic. Anyway, I think I'm going to have to go have a shower, clean my screwdriver. It's absolutely filthy. And, well, hope you enjoyed it. That's a photocopier teardown. And as always, if you want to discuss it, jump on over to the EEVblog forum. And if you like the video, please give it a big thumbs up, because that helps a lot. Catch you next time.